simplest form of autoscaling is to scale a managed instance group. You can autoscale based on load balancing service capabilities, CPU utilization, monitoring metrics, or schedules. We will take a look at all four of these in this demo. Here we see the instance group page. The first thing we would create an instance group. Here you would give the group a name. Next, you would select an instance template. I took the liberty of creating one of these earlier. Next, you would select the zones by which you want to deploy. Here we'll turn auto scaling off, thus to show you how to actually invoke it once we create an instance group. The rest you can leave as a default. Now create. Once the instance group has been created, you would then go and edit the group. Now, as you can see, we turned autoscaling off. We will now invoke autoscaling and initially set it for CPU utilization. We will select Scale Out, only add instances to the group. We will have a minimum number of 1 and a maximum number of instances at 10. Next, we would select the CPU limits by which we would want to scale. Simply select the down arrow and change 60 to 75, for example. Leave the rest of the settings as default, and then click Save. The instance group has been successfully updated and now will autoscale once the CPU utilization reaches 75%. One further note on autoscaler. The autoscaler treats the target CPU utilization level as a fraction of the average use of all virtual CPUs over time in the instance group. If the average utilization of your total virtual CPU exceeds the target utilization, the autoscaler adds more VM instances. If the average utilization of your total virtual CPUs are less than the target utilization, the autoscaler removes instances. For example, setting a 75% target utilization tells the autoscaler to maintain an average utilization of 75% among all vCPUs in the instance group. Next, we'll take a look at predictive autoscaling. Predictive autoscaler forecasts your scaling metrics based on the metric's historical trends. Forecasts are recomputed every few minutes, which lets the autoscaler rapidly adapt its forecast to very recent changes in load. Predictive autoscaler needs at least 3 days of history from which to determine a representative service usage pattern before it can provide predictions. Compute engines use up to 3 weeks of your MIG's load history to feed the machine's learning model. Now we'll take a look at enabling and disabling predictive autoscaling. We'll take a look at our demo group, instance group. We'll edit. Here we find that autoscaling is once again turned off, so we will have to turn this on. Select Add and Remove Instances to the group. Once again, we can specify minimum and maximum number of instances. Next, you will need to select CPU utilization. Under CPU utilization, you will see predictive autoscaling. We will turn this on to optimize for availability. Then select Done. Under initialization period, specify how long it takes for your application to initialize a new instance. This setting informs predictive autoscaler to scale out further in advance of anticipated load, so that the applications are initialized when the load arrives. This is currently set at 60 seconds. Then click Save. You can visualize the historical size of your group using cloud monitoring. The monitoring graph shows how your autoscale configuration scaled your group over time, and it also shows how predictive autoscaling, if enabled, would have scaled your group. Here are the steps. Select Overview of the group that has predictive autoscaling turned on. Then go to Monitoring. Highlight the name of the first chart in the actual Overview section, and then select Predictive Autoscaling. If your service takes a long time to initialize, your users might experience service latency after a scaled-out event. That is, while the new VMs are provisioned but not yet servicing. Predictive autoscaling takes into account your application's initialization time and scales out in advance of predicted increases in usage, helping you to ensure that the number of available service instances are sufficient for the target utilization. Compute Engine provides support for load balancing within your instant groups. You can use autoscaling in conjunction with load balancing by setting up an autoscaler that scales based on the load of your instances. The balancing mode and the target capacity that you specify define the conditions under which Google Cloud determines when a backend VM is at full capacity. Google Cloud attempts to send traffic to healthy VMs that have remaining capacity. If all VMs are already at capacity, the target utilization or rate is exceeded. Compute Engine provides support for load balancing within your instance groups. You can use autoscaling in conjunction with load balancing by setting up an autoscaler that scales based on the load of your instances. The balancing mode and the target capacity that you specify define the conditions under which Google Cloud determines when a backend VM is at full capacity. Google Cloud attempts to send traffic to healthy VMs that have remaining capacity. Now let's take a look at enabling autoscaling based on load balancing server capacity. We'll start at the instance groups. Select an instance group, then select Edit. Once again, turn on autoscaling. Also select your maximum and minimum number of instances. Next, we will add a signal. Then we will select HTTP load balance utilization. Enter the target HTTP load balance utilization. This value is treated as percentage. For example, for 60% HTTP load balancing utilization, enter 60. You can use the cooldown period to set the initialization period, which tells the autoscaler how long it takes for your application to initialize. Specify an accurate initialization period. This improves autoscaler's decisions. For example, when scaling out, the autoscaler ignores data from VMs that are still initializing, because those VMs might not yet represent normal usage of your application. The default initialization period is 60 seconds. Then save your changes. You can set one of three options for your load balancing service capacity. When you first create the backend, you can choose among maximum backend utilization, maximum requests per second per instance, or maximum requests per second of the whole group. For example, if you set a backend to handle 10 requests per second per instance, and the autoscaler is configured to maintain 80% of the rate, then the autoscaler can add or remove instances when the request per second per instant changes. Now let's take a look at scaling based on schedules. Schedule-based autoscaling lets you improve the availability of your workloads by scheduling capacity ahead of anticipated load. If you run your workload on a managed instance group, you can schedule a required number of virtual machine instances for recurring load patterns, as well as one-off events. You can also use scaling schedules if your workload takes a long time to initialize and you want to scale out in advance of anticipated load spikes. Now let's take a look at how to implement scaling based on schedule. Once again, we go to instance groups and select an instance group. From that instance group, we actually select Edit. Here once again, we configure autoscaling. We select Add or Remove Instances to the group. Then we scroll down to Autoscaling Schedule and click Manage. Then we create a schedule. Give it a name, minimum instance, start time, select time zone, duration, 5 hours, every week, and the days of the week that we want to implement. And say OK. Then we select Save. And last, we'll take a look at scales based on monitoring metrics. When you autoscale a MIG based on the metrics, the autoscaler creates VMs when the metric value increases and deletes VMs when the value decreases. For example, you can define how many VMs you need per user count, latency, or the number of messages in a pub sub subscription. You can use either the built-in metrics provided by the monitoring service or custom metrics that you export from your application. Now let's take a look at how we implement scales based on monitoring metrics. Once again, we start at instance groups. We select an instance group. Then we select Edit. Scroll down to Autoscaling. Turn on Autoscaling. Next, we select Add a Signal. Here we select the signal type, Cloud Monitoring Metrics. Next, we would select Configure. Then you would select a metric. In this instance, you would select VM Instance. Here's a list of the different objects we can implement in our metrics. If you select Instance, then you see you have 29 metrics. Disk usage, apply. Here we can implement the metrics according to the numbers that basically work with our application. So we would select metric target options for auto scaling. And last, we would save. In this demonstration, we've explored the powerful capabilities of the Google Cloud Platform for automating the scaling of resources to meet dynamic workloads. By leveraging GCP auto-scaling tools, such as the Compute Engine Management Instance Group, we have shown you how to seamlessly adjust computing resources in response to varying demand. These tools ensure high availability, performance, and cost efficiency by automatically scaling instances based on predefined metrics or custom policies. This automatic approach not only simplifies resource management, but also enhances the overall resilience and adaptability of your applications. With GCP auto-scaling features, you can confidently handle traffic spikes, optimize resource utilization, and maintain a consistent user experience, making it an indispensable part of your cloud infrastructure strategy.